All right, so for example 1, says if cosine of theta is equal to negative 3/5 and theta is in quadrant 2, find the exact value of each of those expressions. And I gave us a separate slide for each one. All right, so we know that cosine of theta is equal to negative 3/5. Now, if you looked at those slides right here, notice we're going to need sine, cosine, and tangent to solve these, right? So why don't we go ahead and find our sine, cosine, and tangent on this first slide. So, because I'm going to have a slide to do A, B, and C on, but I need sine, cosine, and tangent. And it told me that cosine of theta is negative 3/5, and we're in quadrant 2. Why do I need to know what quadrant we're in?
Sine?
Yeah, to see if our missing variable is positive or negative, right? Or if our trig functions are positive or negative. Well, what do we know about cosine? Yeah, it's x over r. So now we know that, well, first let's go ahead and do this piece before we put numbers in there. In quadrant 2, is x positive or negative? What about y? What about r? Good, r is always positive. And so that means that, what is my r value for this problem? R is 5, which means x is negative 3, and we already said it was negative, so just put the 3 there. And how are we going to find y? Yeah, x squared plus y squared equals r squared, right? Alright, so we got negative 3 squared plus y squared equals 5 squared. So it tells me that 9 plus y squared equals 25. So y squared is 16. So we know y is plus or minus 4. And we said we're going to use the positive 4 because we're in quadrant 2.
Are we still doing the same thing? Like we already did this before.
Right, yes, it's just building.
Oh, okay.
Alright, so now that we know x, y, and r, we can also find sine and we can find tangent. So what is sine of x? We said it was y over r, which is 4 over 5. And then tangent of x is y over x, which is, alright, so now we know our sine, our cosine, and our tangent, right? Alright, so for A, I wanted sine of 2 theta. And so if we flip back over to our formulas, we'll see that sine of 2 theta is equal to 2 times sine of x times cosine of x.
I was reading that as 20 the entire time.
Oh.
Oh,
So we have 2 times, we know sine of x. What did we say sine of x was? 4/5. Times cosine of x, which we said was negative 3/5.
I feel like there's so much room for error when you plug back. Like, what are you plugging in? Like, I don't know.
And then we just multiply that all together. And we get guys, on top it's just 2 times 4 times negative 3. And on bottom it's just 5 times 5. And so we get negative 24 over 25. Okay, moving on to B. B is cosine of 2 theta. Now if you look at the formulas that we were given, it has 3 different options. They're all going to give us the same answer. So typically you just look at what you were given and wait to know which formula you want to use. Now we went ahead and we found sine and tangent because we know we're going to need it for all 3 of them. So it doesn't matter. But if they had just told me cosine like they did, and it only said to find cosine of 2 theta, I would use the third one that was written there because it only has cosine in it and I wouldn't have had to find sine. So it doesn't matter. Which formula do y'all want to use? The third one? Alright, so we have cosine of 2 theta is equal to 2 times cosine squared of theta minus 1.
That's theta.
That's theta.
Instead of x.
Oh, you could put x if you wanted to. I just went and put theta because they had theta in the first one. I mean, in the original. So 2, we know cosine is negative 3/5, right? We're going to square it and subtract 1. Remember, 1 is 25 over 25. And so we can get our answer that way.
That's a rough one.
All right, and then C, tangent of 2 theta. So we look back at our little formulas, and we see the tangent of 2 theta is equal to 2 tangent over 1 minus tangent squared.
I really hope on the test I read those 2 theta and not 20. Because I just keep thinking.
All right, well, we know what tangent is. What did we say tangent was? Okay. So plug it in and solve. So I got to this point here where I did keep it, change it, flip it. Now you can multiply straight across and then reduce, but what I did is, remember, 3 and 9 are both divisible by 3, so I just kind of reduced it there. And so I ended up with positive 24 over positive 7.